All right, day 8 is here. Welcome back, Advent of Code. It's Tuesday afternoon, and we are tackling the next step here in Advent of Code. So, I've already got our space set up as promised from yesterday. I wanted to kind of save us a little time, and let's get started. So we'll run up the stopwatch as usual, and here we go. Handheld halting. Your flight to the major airline hub reaches cruising altitude, so we're back on the plane again. We're going to check for one of those drinks. You're interrupted by the kid sitting next to you. Their handheld game console, They ask if you can take a look. You narrow down the problem to a strange, infinite loop in the boot code. Oh boy. This is not, look, I'm not liking this direction. Your puzzle input is an infinite loop in the boot code. All right, so we're gonna write a little parser, potentially a compiler kind of thing. We need to isolate the code. The boot code is represented as a text file with one instruction per line. Each instruction consists of an operation, accumulate, jump, or no op, and an argument, assigned number like +4 or -20. ACC. All right, I'm going to jump down and look at the puzzle input so we can kind of toggle between these two. Okay, so ACC increases a single global value called the accumulator by the given value in the input. The accumulator starts at 0 after an ACC instruction. The instruction immediately below it is executed next. Jumps to a new instruction relative to itself. The next instruction executed is found. Okay, so that's going to mean we're going to need to parse the file and go through the list of instructions on the second pass. Using the argument as an offset from the jump instruction, so jump +2 would skip the next instruction. Jump 1 would continue the instruction immediately below it. Okay, so it is directly relative to yourself. 20 instructions above it, so yeah, -20. No op, it does nothing. The instruction immediately below is executed next. Consider this. Visited in this order. No op. Accumulate 1, so it becomes 2. And then jump 4, so then we go to... why did it become 3? Jump. The next instruction... Jump +1 to execute the immediately below that. Why would that... Oh, this is just the order, I guess. So accumulator is at 1. Jump +4, we go 1, 2, 3, 4. Accumulator +1. Jump -4. 1, 2, 3, 4. Accumulator +3. And then we go to the next one. Jump -3. 1, 2, 3. Accumulator +1. We're at 6. Jump +4. 1, 2, 3, 4. Accumulator +1. Oh, I'm doing something wrong here. Yeah. So it's an infinite loop. This is a sequence of jumps. The program will run forever. The moment the program tries to run any instruction a second time, you know it will never terminate. Yeah, that's fair. Immediately before the program would run an instruction a second time, the value in the accumulator is 5. Yeah, that's what we had. Run your copy of the boot code immediately before any instruction is executed second time. What is the value in the accumulator? All right, so we need to grab the lines our standard way. I think we can safely do that. Let me drop this all in here, and then we're gonna pull out. Let's see. For each line, what do we want to do with this parse? I think I want split on space, and I'm pretty sure if we do int on +34, it'll just be 34. And int -34, of course, will be -34. That one I know will work. And these things, we'll just leave them be. So for each line, we're going to do line.split. And we'll say that this is, instruction, comma, value equals this. Value equals int of value. Return line, return val in instruction value pairs. So we'll have a list of instruction value pairs, which will look like that. I don't know why. I think there's something wrong with that return line when I copied it into this generator. I need to check my generator later. And we have our pairs, very nice. Then we need a third element, which can't be part of. We need to know if we hit an instruction. So we want the index. All right, we can store a set of the indexes. Yeah. So if we have a set of instructions visited, right? So this is indexes visited. Index of instructions visited. And then we can go through each line and jump around. For instruction, comma, val in lines. Nope, that's not what we want. While index not in set, not in visited, index currently equals 0. We'll do lines at index. We'll grab that value out, which is the instructions value. And then we can say if the instruction is one thing, we do that. If it's that, okay. If ins equals ACC, is that what it's called? Then we do value plus a cube total plus equal to value. We need to set that start the total equals 0. Starting to think I should include a total equals 0 in all my template code. And then we'll just go on to the next one. So then we say index plus equals 1. If instruction is, what else do we got? Jump, then we will go to a different line. So index plus equal to value. Do nothing with the total. And then if ins equal to no op, then we'll do index plus 1 plus equals 1 and nothing else. So what I'm seeing here is that we should nest this as follows. We'll put this first, and we can say if it's the first bit here, if we put the no op index plus 1 and index plus 1 here, then we can I'll just leave it as I wanted it to fall through, but it's not worth the trouble. And so then it'll continue. Oh, there's one more thing we have to do. Every time we visit a line, we're going to add that instruction, that index to the set visited dot add index. Yeah. So then we add the index to the visited, then we do the whole thing, and then when we say that it is in visited, the first time we see it, we will have a total, and we will return that total. And that should be our program. Let's get rid of that. And we get a number. I want to test it. Right. I'm just going to do this to save time. We say 5, that is what we expected. Control Z, Control R again, 1941. And we are at 826. We got it right. Awesome. Let's go on to part 2. 826. All right, part 2. Exactly one instruction is corrupted somewhere. A jump is supposed to be a no-op, or a no-op is supposed to be a jump. No ACC instructions were harmed in the corruption of this boot code. Very nice. Immediately terminate by attempting to execute an instruction. Program is supposed to terminate by attempting to execute an instruction immediately after the last instruction in the file. You can repair the boot and make it terminate. So whatever the last index is, which is length minus 1, we want the index that is jumping to be in the length itself. So we want to jump or start executing or index equals length of lines, right? The number of lines. Consider this: if you change the first instruction from no up plus 0 to no up plus 0 to jump plus 0, how'd that be? You create a single instruction infinite loop, never leaving that instruction. If you change almost any of the jump instructions, the program will still eventually find another jump instruction. However, if you change the second to last instruction from jump, so it's a single point mutation, the program terminates. The instructions are visited in this order. No op minus 4. Oh, right, that's the one that used to be a jump. That's this one. And, okay. Interesting. And so after the last instruction, accumulate plus 6, the program terminates by attempting to run the instruction below after the last instruction. Oh, yeah. So we changed the jump. So instead of jumping, we're just kind of running it through. With this change, the accumulator contains the value 8. Fix the program so it terminates normally by changing exactly one jump. What is the value of the accumulator after the program terminates? So our input has a lot. Is this dynamic programming? This is the worst. Okay, so I want to write a function that figures out if a program terminates or not, given its set of inputs, right? And then run through the kind of set of possible commands to see if we ends up, well, we figure out if it ends up terminating or not. We also want to see if it loops or not. So we also don't want it to loop. So basically we can return that it's not what we're looking for if it either loops or doesn't somehow, maybe it jumps past the end by more than one or something like that. Because that's going to break this code right now. Okay. I will keep the parser. And let's see what we got here. So we'll get rid of this line, get rid of that line, paste all that in here. Let's see what we got. So this bit of code will analyze a set of instructions, right? These lines, and when they're this is kind of the looping checker. So I'm going to cut that. I'm going to say define validate program. So this will return true if successful termination, otherwise false. And we're going to pass in the lines. And we're going to do nothing else. And we're going to modify here, modify lines to try different no-op jump swaps. So every time we come across a no-op or jump, we switch it to the other thing. And so we can say, while not in visited, we need something at the end here. Basically, if it loops, we'll know because index will, yeah. And then I guess we have one more check. If index, and we might move this up right before we access anything. If index equals to the length of visited, then return true. Otherwise, return false. And so we have lots of combinations that will cause loops. We have combinations, and so then we can say if index greater than, so we have less than the length, equal to the length, and greater than the length, then we also return false, because that's also invalid. And we're checking where we're at. We're returning false on the thing. So now we're just going to iterate through every single line for line in lines. if I'm forgetting what it looks like, and I took away the print statement, so yay me. I'm going to take away this call so that we don't run the first part every single time. Where do I print it before? Oh, I just returned it before. Haha. I guess that's fine. Okay, there we go. So if, oh, I guess that's what it was. I forgot. Instruction, comma, value in line. If instruction equals to jump, then we will modify that particular one to be no op, and we'll get the value again. So we'll say it's no op, comma, the same value is the new thing in that spot. So I'm thinking enumerate lines, which will give us index. Eesh, I don't know if that'll actually work the way I think it will. Did not enough values to unpack, expected 3, got 2. Yeah, that's what I was worried about. So they wanted that, and int object is not iterable. Lines is this, and we're getting those pairs back. Oh, is it? I got it reversed. All right, it's index followed by value. There we go. So I'm printing no op, then the value, then I, which, yeah, it's a little backwards, but it works. All right, good. So if instruction is jump, then we can, I don't remember if there is a, oh, it doesn't matter. We don't need to. I was going to say that there's a replace in Python, but we don't need to worry about replace because I can just say lines at I is now replaced with no op, comma, value. Ooh, only temporarily though. Only temporarily. So I want to say new input equals lines plus bracket. Now we can say new input. At I is because we only want to switch one, and then we want it to go back to. We're not switching, every single one, every combination, because that would get really ugly really fast. If the instructions is no op, this is the same thing but reversed. Then it's jump. And for each of these, or I guess whichever one it is, we do the swappy, and then we say new input is the input to our little function whose name I've already forgotten, validate program, new input. And so if, what do we have to return? Value of the accumulator. Blast. Terminates normally by changing exactly 1, and then what is the actual value of the accumulator upon termination? Okay, not what I expected. So let's return false comma total, whatever the total happens to be. We're just gonna throw that in there, and yeah. So we'll call that, we'll get the total. So we'll get total, we'll get valid, whoops. And so if valid, return total. Yeah. And this should never execute. Return what? We'll run it, we get 0. Cool. I don't believe you. Wait, seriously? It returns 0? No. Valid, comma, total. These should have all returned a bunch of values. Okay, let's see how many we're getting through. 0. Okay, we got through 1. That was the problem. So why is it 0? Total, it might duplicating local variables by accident. Jump 265. So that's like the first thing we see, right? Is like the first command we see is jump 265, and we would switch it to no op. And so then the new input is that. I guess it doesn't, we can move this up a level. Not that that'll change anything, but you know. And then we say, depending on which one it is, we make a change. I'm guessing the error is in my validate program. This looks right. So in validate program, since we're only running through it once, apparently, we're getting lines. We're adding all this together. Like, part of me, I think, is because of the way we restructured this. If index is greater than length, return total. Oh, right, because total is 0. So that means we jumped straight through while index not in visited. Visited is the empty set. And we say if index is greater than the length of, visited. That's the problem. It's the length of lines. Yeah. All right, now we're talking. So we tried 425 combinations and we got the one we wanted. Oh, wow. Hit it. All right. Nice. 21 minutes. We'll take it for a little parsing action. Not the worst. Got through it. This is a good one. This is a little bit reminiscent of last year's int code compiler thingy. If you go back to 2019, like day 4, I want to say, it started showing up, and it showed up like again later. Like I could see a scenario where we end up kind of like meeting this kid again somehow, or meeting another handheld toy, and we're gonna have a significantly more complex set of instructions in that one. They're gonna ask us other questions. It won't be looping, it'll be something more elaborate. But I think I will hold off on like creating like a handheld toy class or anything like that. This is, I haven't seen enough of the overall structure of where this is kind of going to be able to kind of make those modifications in an informed manner. I think that would be premature optimization to some degree and kind of over engineering this. So I'll leave this as is. It's reasonable-ish. I'll turn this back on and make sure we get the, turn off the copious print statements I've got running here. This one specifically. There we go. Now I got our 2 numbers, and I guess that means we're good to go. Good to git add, git pull, and git push. And I apparently, what? Oh, I didn't git commit. Sometimes. Day 8. Git push. Good. So that's a wrap. Let me know if you found a better way to solve this. I'm sure you did. And yeah, leave a comment, throw down a like, subscribe, do all that stuff. And we'll catch you tomorrow.